So today we're going to talk about the surface area of a prism. Prism is any three-dimensional objects where you have polygons making up the sides. The bases are going to be congruent polygons as far as we're concerned, and those polygons are going to be connected by rectangles. Prism is named based on the shape of the bases. Over here on the left we have a triangular prism, and in the middle we have a square prism, which we more typically call a rectangular prism. On the right we have a hexagonal prism because the bases are hexagons. To find the surface area of a prism, one technique that we can use is called drawing a net. A net is where you unfold that three-dimensional object. So if I was to unfold this, I would draw this rectangle on the front first, and then I would write the length and width of that rectangle inside the rectangle. So this is going to be 6 by 3. I would fold this rectangle on the right, out to the right, and that would give me another rectangle, which was 8 by 3. The right-hand surface is going to match the left-hand surface, so that'll be another rectangle that's 8 by 3. I'd fold this top rectangle up, and that would be 6 by 8. And the top should match the bottom, so I'm going to fold the bottom down to give myself yet another rectangle that's 6 by 8. And all that's missing now is the back. And when you draw this net, you can bring the back along with the right-hand side, or to the left, or you can bring it with the top, or down with the bottom, and it's really wherever you have space to draw it. So for me, I'm going to draw it down below, and it's going to have the same dimensions as the front. It's going to be 6 by 3. Once I draw that net, I can find the area of each individual surface by using the area formula for a rectangle, which is area equals length times width. So when I do 8 times 3, I have 24. 6 times 8, 48. 6 times 3, 18. 8 times 3, 24. 6 times 8, 48. And 6 times 3, 18. To get the total surface area, I need to add the areas of all my surfaces. So I'm going to have the two 48s. I'm going to have the two 24s. And I'm going to have the two 18s. So when I find that sum, I have 48, 48, and 48, so that's 144, plus 18 and 18 is 36, so that's 180. And then my unit, whenever I find an area, is a unit squared, so this would be meters squared. And it's a surface area. With surface area, a lot of times you'll see it written capital S, capital A. Another way that you might see surface area written would be an A sub S, or some people will just do a capital S. All of those are accepted forms for surface area. So we can use that technique again to find the surface area of this rectangular prism. I would start by drawing the rectangle on the front and writing its dimensions, which are 3 by 10. I would fold the right-hand side out to the right, which is 2 by 10. And the left-hand side over here to the left, which again, 2 by 10. And you don't have to draw this to scale, just do the best that you can. I'm going to fold the bottom down. When I fold that down, that's 3 by 2, and the top up. Right? The top is going to go up. So that'll be 3 by 2 as well. Then I'm going to take the right-hand side, and then, actually I already used the right-hand side, but I'm going to pull the back with the right-hand side and draw that extra rectangle that matches the front, which is 3 by 10. The area of each rectangle can be found using length times width. So 2 times 10 is 20, 3 times 2 is 6, 3 times 10, 30, 2 times 10, 20, 3 times 10, 30, and 3 times 2, 6. For the total surface area, I have to add the area of each individual surface So I have the 2 6s, I have the 2 20s, and I have the 2 30s. When I add that together, I get 112. My unit is always a unit squared with an area, so in this case it'll be feet squared. That little dash stands for feet. If there are two of these, like if we were to write this, this would be 6 inches. But a single dash, feet. And then again, this is a surface area, so I could write A sub S or capital S, capital A. Here the directions ask me to find the surface area of a rectangular prism with the given dimensions. So that technique of drawing a net worked just fine for us, but we don't always have to draw a net. What we could do is we could use a formula based upon what we learned by drawing a net. And if you notice on all these, the front matched the back, the left matched the right, and the top matched the bottom. So if we call the dimensions on the sides of the rectangle length, width, and height, what we really do is we end up doing twice the length times the width to find the area of the bottom and the top, twice the width times the height to get the left-hand side and the right-hand side, and twice the length times the height to get the area of the front and the back. And then all we have to do is add those together. And that is our surface area formula for a rectangular prism. It'll always work. So we'll use this formula to do the next 3 columns. So surface area is equal to twice the length times the width, plus twice the width times the height, plus twice the length times the height. So in this problem, surface area is equal to twice 8 times 2, plus twice 2 times 7, plus twice 8 times 7. So 2 times 8 times 2 is 32, 2 times 2 times 7 is 28, and 2 times 8 times 7 is 112. So when I add these together, 32 plus 28 is 60, plus 112 is 172. And since it's an area, it's going to be a unit squared, so we're going to have feet squared. For part B, if you notice, we have these dimensions of 25 centimeters by 125 centimeters by 1 meter. So our dimensions don't match because our units don't match. So what we want to do is convert whatever's easiest for us. Since I already have 2 in centimeters, I'm going to change this 1 meter to 100 centimeters. And again, I'm going to use that formula, so I'm going to write it. Surface area equals twice length times width, plus twice width times height, plus twice length times height. So surface area is going to be equal to 2 times 25 times 125, plus 2 times 125 times 100, plus 2 times 25 times 100. So if you wanted to, you could just put that all on your calculator at once. For me personally, I break it down and just do my products first. So when I do 2 times 25, that's 50. 50 times 125 is 6250. 2 times 125 is 250. And then we put the 2 zeros on the end, so that's 25,000. 2 times 25 is 50. We put the 2 zeros on the end, we have 5,000. When I find that sum, I end up with 36,250, and it's going to be my unit centimeters squared. If you wanted to convert that to meters squared, you could. A square meter is 100 centimeters by 100 centimeters. So you divide by 10,000. because 100 times 100 is 10,000. And then you could get this measured in square meters instead of square centimeters. On part C, we have inches, inches, and feet. So again, I'm going to convert my feet to inches because I already have 2 in inches. So 2 feet is 24 inches. My surface area formula hasn't changed. It's twice the length times the width, plus twice the width times the height, plus twice the length times the height. So I'm going to have surface area equals 2 times 20 times 18, plus 2 times 18 times 24, plus 2 times 20 times 24. So 2 times 18 is 36, times 20 is 720. When I do 2 times 18 times 24, that one's a little bit more challenging. We're going to have to do 36 times 24. 36 times 24, well, if I did 36 times 20, that would be 720, and then I need 4 more 36s. 4 more 36s is 144. So if I have 144 plus 720, that's 864, plus 2 times 24 is 48, times another 20 is 960. So when I add those up, I have 4, another 4, I have to carry a 1, so I'm going to have 2,544, and again my unit will be squared, so I'll have inches squared. If for some reason I wanted to convert that to square feet, a square foot is 12 inches by 12 inches, so 12 times 12 is 144, so I can divide this by 144 and get my answer in square feet. The bases of a prism are right triangles whose edges measure 5 meters, 12 meters, and 13 meters, which is a Pythagorean triple. The lateral sides of the prism are perpendicular to the bases. The height of the prism is 20 meters. So I'm going to draw a picture here where I draw those right triangles as the bases. I draw one right triangle and then I try to draw the same right triangle up and to the right. And then I connect the corresponding vertices so that I get that optical illusion of a 3-dimensional shape. We should know that the legs are the shortest 2 sides in the right triangle. So my legs are going to measure 5 and 12, and then the hypotenuse is going to measure 13. And you can write that information on either of the triangles because they're going to be congruent. The height of a prism is the distance between the bases. So the height could be this segment or this segment or this segment, and that's 20 meters. The first question that I'm asked is, what shape are the lateral faces of the prism? Well, in our prisms, our lateral faces are always going to be rectangles. It is possible to have a prism where you have a shape other than a rectangle, but in this course we never will. What are the dimensions of each lateral side of the prism? If I want to find those dimensions, I might just unfold it and draw them. So maybe I start with this rectangle down at the bottom. And the rectangle down at the bottom is 12 by 20. Then I can take this right-hand side and fold that up to the right and draw that rectangle, which would be this dimension, which is the 13, by this dimension, which is the 20. And then I have the sort of left-hand side, or maybe some of you might call it the back, and I would fold that to the left to draw another rectangle that's 5 by 20. So that shows the dimensions of all the lateral sides. Remember, the lateral sides are the sides that are not the bases. So these triangles are the bases. The other surfaces are the lateral surfaces. What's the total surface area of the prism? Well, to get the total surface area, I need the area of all the surfaces. So I might start by finding the area of these 3 rectangles. The area of a rectangle is equal to length times width. So 5 times 20, that's 100. 12 times 20, that's 240. And 13 times 20, that's 260. So far, I have 100, I have 240, and I have 260. But I'm missing those triangles. I'm missing those two bases that are the triangles. And with the triangles, to get the area of a triangle, you really need to know the lengths of the sides that are perpendicular. So if we turn back for just a second, the perpendicular sides have lengths of 5 and 12. They're the sides that make the right angle. So I turned the page the wrong way. So we're going to have a 5 by 12 and then another 5 by 12. The area formula for a triangle is equal to base times height divided by 2. So for each of these, I'm going to do 5 times 12 divided by 2, which is 30. So the area of each triangle is 30. So I have to add those in as well, 30 and 30. So when I add the zeros, I get a 0. When I add here, I have a 6. I carry the 1. I have another 6. This is the surface area, so I could write S equals. And then I need to make sure that I write my unit if there is a unit. In this case, it says the unit is meters. So when we have that unit over here, it'll be meters squared. The bases of a right prism are isosceles triangles. The lengths of the sides of the bases are 17, 17, and 16. The length of the altitude of the triangle drawn to the shortest side of the base is 15. The height of the prism is 14. So I'm going to draw isosceles triangles as my bases. I'm going to draw a triangle with two congruent sides. Then I'm going to draw the exact same thing up and to the right, to the best of my ability, an isosceles triangle. Then I'm going to connect the corresponding vertices to get that illusion of 3 dimensions. It says the lengths of the sides of the bases are 17, 17, and 16. So those are the sides of the triangle. And my congruent sides have to be the 17 sides. So this is a 17, this is a 17. I'm going to write a 17 out here to show that. And then my base is 16, so maybe I put that down here. It says the altitude drawn to the shortest side of the base is 15. So the altitude is going to go from the vertex to the shortest side, 16. So I'm going to drop in an altitude right here and make that 15. And then the height of the prism, that's the distance between the bases, that's 14. Again, we have that question, what shape are the lateral faces of the prism? Rectangle or rectangular. What are the dimensions of each lateral side of the prism? I would draw that, and I would start with this rectangle at the bottom. So when I draw this rectangle at the bottom, its dimensions are 16 by 14. I would take this right lateral surface and fold that down to the right. When I look at the side lengths on this, it's 17 by 14. And then I'm going to have a matching lateral surface to the left, so I'm going to draw that as a rectangle as well, which is 17 by 14. So I've given the dimensions of each lateral side of the prism. What's the total surface area of the prism? Again, total surface area, you need to know the area of all the surfaces. So for the area of a rectangle, we'll have length times width. So when I do 17 times 14, I'm going to have 170 plus another 68. So that would be 238. And I have 16 times 14, that's 224, because it's just 114 less than 238. And we already have 17 times 14, so that's 238. So I have my 238s and my 224. And then I need the bases. The bases were those triangles. And whenever we find the area of a triangle, the base and height have to be perpendicular, so we need dimensions that are perpendicular. So if I look at my picture back here, that's why they told me the altitude was 15, because the 17 wasn't going to be that helpful to me, unless I used Pythagorean theorem. So in this case, we're going to use the 15 and the 16 to find the areas of these triangles. 16 times 15 divided by 2, which is really just 8 times 15, or 4 times 30, which is 120. So the area of each triangle here is 120. So I can add those to my list of individual areas. When I add these up, 8 plus 8 plus 4 is 0, carry the 2. 2 plus 2 plus 2 plus 6, because the 3 plus 3, plus that extra 2 that we carried, right, is going to be a 2. No, it's not. 6, 6, 4. Carry the 1, and then we're going to have 3 and 6 is 9. And so our unit with this, we don't need a unit. If they don't give you a unit in the given, you don't have to write a unit in your answer. So I'm going to say 940. If I wanted a unit, I could write unit squared, or I can just leave it blank because they didn't give me a unit. So that's your brief lesson on surface area. Good luck with your homework.